Hello and welcome back to my channel. So I thought I'd give you a little update on what I'm doing with my prosthetic hand project. The last time I made a video on my aluminum hand, I had just completed the splay function and was going to add the electronics to give me individual control of the fingers. Well, after a pile of trial and error, I came to the conclusion that it was just going to be better to start over with building a new hand. So it's been about 4 months since I switched to the aluminum hand as my daily driver. Overall, I'm still really pleased with the device. Throughout that time, I've yet to break any of the finger components, which is awesome, compared to all the previous devices that used 3D printed fingers. I would have had to make several sets of replacement fingers during that same amount of time. On my last plastic hand that had printed fingers, I found that they had an average usable lifespan of about 3 weeks of daily use. Then the hinge points would start to fail. The pinky and index were of course subject to higher failure rate due to their proclivity to lateral impact. I would usually experience breakage of the MCP or PIP joints. I also noticed age-related failure due to UV exposure over time. That's where the aluminum fingers really come out on top. They may weigh a little more, but the fact that they're just that much more durable is really beneficial in the long run. Which brings me to my new hand. After a couple months of daily usage, I've managed to come up with a relatively short list of things that I'm planning on changing. So things that I found that I want to change are, I want a little more grip force, so that necessitates a change in the location of the fulcrums. I still want to have the total wrist travel be around 38 degrees. I plan on being able to increase the force by increasing the lever arm length just a little bit. That ties into something that I've been working on for quite a while now, that involves an automatically adjustable bell crank. This assembly would be set up so that when the fingers are under little load, the length of the output level would be long, making the fingers close really fast. But once the fingers meet with resistance, the length of the output would automatically shorten, and while the speed of the fingers would slow, the amount of force generated by the fingers would increase dramatically. The difficulty with this is you don't want to use up a pile of wrist travel, making the bell crank change its ratios. You want it to happen over just a couple degrees of wrist motion. I also want to move the point of rotation of the MPJ. The current design has the base of the finger being composed of 3 pieces. The new one is made of 1 and will shorten the overall length of the finger by almost a half an inch. This should also help with the grip strength by shortening the overall length of the finger assembly. Another change related to the MPJ is putting all of the motion components in a linear rail so it can get rid of the bend that the chain picks up when the fingers are closed and splayed. There's nothing really wrong with it functionally. Everything moves smoothly and returns to home just fine. I just don't like it from an engineering point of view. So enclosing everything in a rail should fix that. Something else that I'm looking at changing is currently the fingers are linked together 1 and 2 and 3 and 4. Problem is, if I lock the ring and pinky, I think that I'm potentially losing out on a pile of mechanical advantage that I could have if I linked them 1 and 3 and 2 and 4 instead. It adds a bit of complexity, but I'm willing to give it a try. The fingers themselves I've been very happy with. All of the lengths and travels work out well, so no changes there, other than maybe finally adding the magnets and fingernails. One final change is the placement of the servos for the locking mechanism. Right now I feel they're a little exposed and could be subject to breakage. I haven't broken any yet, but I could see where it could become an issue over time. So I'm looking at putting them in the front center of the MPJ base. The design looks good in CAD, but I'm going to mock one up in resin and aluminum just to make sure before I get too far down that road. Occasionally I've been working on the Arduino program. Got the program down to 65% of the processor's capacity. It's still got a couple bugs in the settings save function, but I'll eventually get it. I have to say I've gotten a lot better writing script now than I was at the beginning of this adventure. I've been running into a bit of a roadblock on the current iteration with the placement of the dry contacts for the Myo amplifiers. They have to be within a very small placement window for everything to work correctly, and to still have 4 individual, reliable signals. Where I'm trying to spring mount the contacts onto the wire socket, what I'm finding is that as I move my hand to generate the signals, I lose reliable connection with the contacts, which ends up giving me inconsistent readings to the amplifiers. So on the new build, I'm going to start by making a silicon glove and mount the dry contacts in it. Then lay up a fiberglass hard socket to fit over the silicon glove. I'm looking at laminating the signal wires into the fiberglass to help with wire management. I've got a good bit of the forearm parts already built. That's where I'm going to focus most of my attention right now. After I get the hard socket built, I'll build a new Gaffney and wrist gimbal. Then I'll be able to get all the electronics dialed in and reliably working before I go about building fingers and placing the mounts. That's where today's video comes in. I thought I'd show you how to use Alumilite silicone putty to make a socket liner. First thing I do is make a plaster positive, like what I've shown in previous videos. That'll give you something to press the silicone against that's a little more rigid and stable than your natural hand. So this product is a two-part putty. It's FDA and food safe, and it ends up being about a 25 or 30 shore, so it's a little bit spongy, but still pretty durable. I haven't had any problems with it ripping or coming apart with the little parts that I've used it for in the past. One thing about working with this stuff, though, is it is fast. They aren't kidding about the 2 minutes to mix and demold in 12, so keep that in mind. What I found that can increase your working time just a little bit is to put both tubs in the freezer for about 15 or 20 minutes beforehand. It won't give you a lot more time, but I've got an extra couple minutes out of it. That's what I'll be doing today. So I drew out the rough pattern on a sheet of paper that I'll need to cover the plaster hand. I covered that with a piece of saran wrap because this stuff sticks to everything before it's mixed and curing. I'm using the 2 steel rules as guides to roll it to a consistent thickness. I'm aiming for 1/8 of an inch, or about 3 millimeters. So I start out by measuring enough of the part A to cover half of the part that I'm trying to make. After you think you have enough, add just a touch more, just to be sure. Measure out the same quantity of part B. Roll each part into a ball and make sure both of them end up about the same size. I'm just eyeballing it this time. I suppose you should probably use a scale and check weights, just to be sure you have equal parts. But I haven't ever had a part not cure, so I imagine that if you're in the ballpark, it'll work out. So after you have both parts A and B measured out and in your hands, take this time to make sure that you have everything you need laid out and ready, because once you start, the clock's ticking. Not that it's $1 billion, but this stuff is kind of expensive to be making too many mistakes with. So let's get started. Start by thoroughly mixing the 2 parts together so you don't have any stripes. You want a nice even color. Remember, clock's ticking, so hurry up. You don't really want to be worrying about camera position and framing. So now that you have it sheeted out, about big enough to cover most of the line drawing on the paper, let's get rid of the rulers and drape the silicone over the plaster. Start working on joining the seams. Be sure to rub the 2 edges together so they become one. Here I was a little leery about ripping off this piece and adding the excess to another place on the form, but it seems to have worked out pretty well. Be sure to keep holding the putty into any hollows, like what I have in the center of the palm of my hand. It kept wanting to lift up, like it had air trapped underneath it. Eventually, I worked the air bubble out and it stayed down. Continue to work the putty all around the form. At about 5 minutes from when you started mixing, you'll notice it'll start to firm up. When that happens, you need to be really pretty close to having everything in its final shape. Start working on smoothing out any ripples or waves that you have on the surface. Be sure that your seams are nice and smoothed out. I kept going back and pressing in on the pocket in the center of my palm, just to make sure that it wasn't lifting. So after about 8 minutes, the silicone starts to really firm up. You'll notice that as you're working the silicone, that nothing really happens. At this time, it's important to just stop. No good will come from continuing to work the putty. Just step away from it and let it fully set up for a couple hours before you try to remove it from the positive. I gave it about 4 hours, and it was fine. I started by making a single cut behind the thumb that continues to the wrist. It'll take a couple swipes with a razor to get through the silicone. Once you're through, make a couple cuts in front of the thumb so you don't end up ripping the silicone while getting the plaster positive out of the glove. Now that you've carefully removed the plaster from the glove, use some scissors to cut the silicone around the thumb so that your hand fits in the glove and it doesn't bite you anywhere. It's really important that the liner fits comfortably and doesn't rub or cause any discomfort when it's on your hand. Now that the glove fits nicely on my hand, I put the plaster back into the silicone liner that I just made and made a wax mold of the outside of it so that I can make a plaster form to lay up the fiberglass hard socket that the silicone liner should fit snugly into. After the hard socket is made, I'll turn a new set of dry contacts that screw together to fit into the glove. There's a link in the description to the Amazon listing for the silicone that I used for this project. Please click on the link so I can get credit on my Amazon affiliate account. Well, that's where I'm going to end this video. I hope everyone is doing well in the zombie apocalypse going on out there. Be sure to like, subscribe, and share the video. And if you have time, leave a comment in the comment section to let me know what you think. Thanks for watching.